subtopic 5.2 that talks about friction. The first question asks about the definition. We know that friction force is always opposite to direction of motion and it slows down the speed of the object. So the best description here is C. It's a force that opposes the relative motion between two surfaces in a direct contact. One more point, we know that friction force is considered as a type of a contact force. Contact force because it requires a direct contact or a direct touch between the two surfaces. Next question here. We don't forget we're always having keywords. These keywords are provided to help you to know the answer without even wasting your time. Here, an object is being pulled across a rough surface by a force F to the right. Then the object remains at rest. So this is our keyword. Remains at rest. This means the type of friction force is static because we have two types, either static or kinetic. Static shows when object is at rest, or while kinetic when object is in motion or when object is accelerating. So the keywords here, it helps us to understand that the object is at rest. So the type will be static, which is option A. Next, we have, this is like a bank word. These different definitions or descriptions, we need to understand which word will be filling the blank here. As usual, we're going to try to find the keyword. The force of what depends on the normal force exerted by an object when there is no motion. So no motion, automatically will think of static friction force. So this is number one. Then something is always less than the maximum value of static force. We know kinetic friction force is always less than the magnitude of static, so it would be kinetic friction force. Okay, the something is needed to calculate the force of kinetic friction force. We still have coefficient of kinetic, coefficient of static, of course, kinetic, coefficient of kinetic, and the last one, something is greater than the coefficient of kinetic, which is the coefficient of static friction. Here, for drawing a free body diagram, also keywords will help us to know which free body diagram is representing the situation. It's written here, a force is applied, the box moves to the right with constant velocity. Constant velocity, same situation as being at rest. So being at rest or moving with constant velocity, in these two cases we have zero acceleration, which means zero net force, which means zero net force. Zero net force doesn't mean we have no forces. No, it means we have forces, but they are opposite and equal, so they cancel each other out. Now, this box is found on a surface, so automatically the first two forces will be drawn. We have downward gravitational force and upward normal force. Now, it's a constant velocity, so we have, this is the applied force and the backward friction force, and all these forces are equal and opposite. These two equal, so they cancel each other out. These two equal, they cancel each other out, so it looks as C. Question 28 is kind of having same concept, but the only difference here, it's written that the box is accelerating to the right. So net force is not zero anymore. If we need to draw free body diagram, so we have, as usual, downward gravitational force, upward normal force. The box is accelerating to the right, so this force has to be longer than the friction force. So the correct option that describes the situation here is D. This is a calculation. We're going to use the formula, which is, of course, you'll be providing with the formula. You don't need to memorize any of the formulas. So friction force can be calculated as mu, which is the coefficient, times Fn, which is normal force. Normal force in this scenario is equal to gravitational force, which is equal to m times g. So here, by underlining our given, the box is at rest. The mass of the box is 150, so this is the mass. The coefficient is 0.30, so this is the coefficient. We need to find maximum static force. So we're going to use the formula, which is friction force is mu times Fn. We know Fn is m times g, so automatically we'll substitute. Coefficient is 0.30 times mass as 150 times 10 or 9.81. By calculating, the answer will be 450 Newton, which is option B. I think no more questions related to friction anymore.